Okay guys, so in this video I'm just gonna go over the whole study guide question by question, answering everything. Alright, so the very first thing that I want to do is question 1. Okay, there we go. Okay, so in question 1, you just have to find all of the given angles. You want to find all the angles given that measurement of angle AHF is 65, and AHF you can find it down here. So this angle is 65 degrees. Okay, now with that angle I can find this angle, which is vertical to this one. So this one therefore is also 65 degrees. Now with this angle, or either one, I can actually find the next one, which would be this one. Well, if you notice, this original angle and this one, both of them together, make up a whole straight line. So then these two angles are supplementary, and because they are supplementary, that means this angle measures 115 degrees. 115 because 115 plus 65 will be 180. So these two angles together are 180. Now with that angle, now I can find this one, which is vertical. So these two red ones are vertical angles. So this one is also 115 degrees. Okay, now let's say that I'm just taking a look at this angle right here. Okay, this angle is an interior angle. Well, alternate interior to this angle would be this angle right here. So because this angle here and this black one, these two are alternate interior, therefore they are both the same. So this one is also 65 degrees. Now because that one is 65 degrees, this one will also have to be 65 degrees because they are vertical angles. Therefore, now if you just take a look at, let's say, this one, okay, and this one, these angles, well, both of these angles together, this green one and this blue one, both of them make up a whole straight line. So then this one has to be 115 degrees. That would be because it's supplementary to this one. And not only that, you can say that technically, let me use this color. Technically, this angle right here is alternate exterior to this angle right here. So they have to be the same, and they are. Alright, now with that being said, that means this angle right here has to be also 115 degrees. That is because this angle in blue is vertical to this angle in blue, and they have to be the same. And that's it. These are all the angles. Okay. That being said, let's go to this. I'm actually going to skip question 2. Let's go to question 3. I'm asking you to draw an example of a parallelogram, but I'm asking you to use the necessary symbols. I need you guys to look for the symbols. Every time you see these symbols, they can help you actually answer the question. Alright, so I just want a parallelogram. I don't have to make it perfect. If I had a ruler, I would try to make it perfect, okay? But this is my parallelogram. Well, it may look like a parallelogram, which it doesn't. But I just need the symbols. The symbols are what will define this as a parallelogram. So here's one arrow. Here's one arrow. That means these two segments are going to be parallel. Then this one will need double arrows. And this one will also need double arrows. That means that these two are parallel. So there you go. That is my parallelogram. Two opposite sides, two sets of opposite sides that are parallel to each other. So that's it. That means this line right here is parallel to this line right here. And this line right here is parallel to this line right here. That's it. It's just the shape with parallel opposite lines, opposite parallel lines. With that being said, let's go to question 4. Have to complete all of these proofs. So what I'm going to do is I'm just going to write the solutions. Okay, so right here. Let's begin. So let me just begin by writing the given statements. Okay, I know that segment. Where's the segment tool? Here, I know that segment OP is congruent to segment PQ. This is true because it's given. It's a given statement. You see the double marks, the double arrows? It's a given statement. Then the next statement will be these ones with the single tick marks. So NO would be congruent to segment NQ. And this is also a given statement. Now the next statement, it's not given. But here's the thing. When two triangles share a side, that means that this side right here, the third side, is congruent to itself. That means that segment NP is congruent to itself. NP. Okay, so NP is congruent to NP. Now, this is not a given statement. This is true because of the reflexive property. So that's it. I want to prove, here's the thing, I want to prove that triangles are the same. This is what I want to prove. That means that that's because it is what I want to prove. That's supposed to be the last thing that I'm going to have in my proof. And I have everything that I need to prove that triangle NOP is congruent to triangle NQP. And that is because of the side-side-side triangle congruence theorem. And that's it. You will be done. The triangles are congruent. We finished the proof. All right. Going for question 5 now. Okay, so in question 5, let me list the set of given statements. So that would be the angles. So I'm going to take this angle F and angle H. Angle F and angle H, I can call them just like that. Angle F and angle H. And that is what I'm going to do. Okay, so I have angle F is congruent to angle H. Okay, that is a given statement. And this is true because this angle right here it's not letting me draw because this angle right here is congruent to this angle right here. Angle F and angle H are congruent. They are the same. Both of them have a single arch, so they are the same. Okay, now the next one would be this one right here. Now here's the thing. This one, you don't want to call it angle G because angle G, as you can see, G is this point right here. Now, angle F was okay to just call it angle F because there are no more angles around angle F. There are no more angles around angle H. So that is fine. But you cannot call this one angle G because if you notice, angle G could be this angle right here. It could be this angle right here. Or it could be both angles together. Okay, so you don't want to be ambiguous and call it angle G. With angle G, you have to be specific with these two angles. Okay, so the first angle, I'm going to call it angle FGI. An angle FGI is congruent to angle HGI. Okay, so that the angle FGI would be this angle on the left, and angle HGI would be this angle on the right. They are congruent. That's a given statement because I have the marks. Then again, they are the angles are sharing a side. Well, that means that that side GI is congruent to segment GI. So segment GI is congruent to itself. Okay, so this would have a little tick mark right here because this segment is congruent to itself. Now again, this is not a given statement. This is called the reflexive property. All right, we have three things right here. We know this angle right here, this angle right here, and this segment right here. I have enough information to prove that both triangles are congruent. Okay, now the congruence theorem that I'm going to use right here will be the angle side. Okay, we have an angle right here, another angle right here, and then the side. Okay, this would not be angle side angle. For this to be angle side angle, then the side has to be in between both angles. That would be right here, but it's not. It's clearly not in between both angles. It's right here all by itself. So this is angle side. So triangles, the triangles are congruent by angle side. I'm just going to copy this to make it easy to write the two angles, the two triangles. So the first triangle, it's FGI. So triangle FGI, which is the triangle on the right, on the left, is congruent to triangle HGI. So these two triangles are the same. They are the same. They have to be the same. Now, because both triangles are the same, that means that the corresponding parts will be the same. And corresponding parts would be like this segment right here and this segment right here. They have to be the same now because they are corresponding parts. That means that these two sides will be the same, even if they're not marked. Because I've proven that the triangles are congruent, then the corresponding parts will also be congruent. That is what we call CPCTC. Corresponding parts of congruent triangles are congruent. Well, if these two sides right here, if these two sides are congruent because they are corresponding, then that means that this side right here is congruent to this side right here, even if it doesn't have the marks. This side will be congruent to this side because they are corresponding parts. Okay, and that is what I want to prove. This is specifically what we want to prove, and I'll explain to you why. Okay, sorry, I'll explain to you why right now. First, let me write that segment FI is congruent to segment IH. So segment FI is congruent to segment IH. Okay, that would be these two segments right here. They are congruent because of CPCTC. That's why they are congruent. Okay, now here's the thing. You have to pay attention to what we are trying to prove. We are trying to prove that point I, that is this point right here, we're trying to prove that point I bisects segment FH. FH is the segment from here to here. So we're trying to prove that point I, which is this point right here, we're trying to prove this point is cutting FH in half. And well, the only way to prove that it's cutting it in half is if we can prove that this half is the same as this half. And because we have shown that Fi, which is this half, is the same as Hi, which is this half, that means that point I bisects segment FH. And that's it. That is why we had to prove that. And instead of writing the whole word segment, let me just write FH. Okay, so point I bisects segment FH. Definition of bisector segment. So that would be it. This is it for question number 5. All right, question 6. I want to prove that angle CAB is congruent to angle CDB. Okay, I'm given something right here. I'm being told that segment line CD is congruent to line AB. CD is up here, so I know this line right here is going to be parallel to this line right here. So this line going like this is parallel to this line going like this. These two lines are parallel. So that's some good information, okay? I'm going to use this information kind of like it's very similar to this one because these two are parallel. We get that all of these angles are very similar. So I'm going to use the same idea. All right. So here's the problem. Okay, so let's begin writing everything I know. Okay? I'm going to try to prove that this triangle right here, ACB, would be congruent to CDB. This is going to help me prove, ultimately, that angle CAB is congruent to angle CDB. Now, how am I going to do that? Well, let me first prove that these two triangles are the same. Okay, let's do that. First of all, let's gather everything that I know that it's given to me. I know here that this angle right here, it's congruent to this angle right here. That's a given statement. Let me use this. Just the symbols are actually... Okay, so angle ACB, which is this angle up here, would be congruent to angle CBD. All right, that was a given statement. Perfect. That was given. All right, now if you notice, these two triangles, they are sharing one side. So because they are sharing that one side, that means that this side right here is congruent to itself. Okay, that side is congruent to itself. Let me just use this one. Okay, that side is congruent to itself. So CB is congruent to CB. CB is congruent to CB. Okay, this side is congruent to itself. How do I know that? Well, because of the reflexive property. All right, so far, perfect. Okay, now here's the thing. I need another set of angles. That would be great if I can get another set of angles. Now notice this here. This line is parallel to this line. Okay, and this line right here, it's pretty much very similar to something that I have that we did up here. Okay, if you notice, this angle right here that was given is congruent to this angle right there. That's because they are alternate interior angles. Okay, well, check this out. There's another set of alternate interior angles, which would be this angle right here and this angle right here. These two angles are also alternate interior. And let me put double arches because the given statements, this one and this one, already have one arch. So let me put double arches for this angle, for these angles. Okay, so that means this angle is the same as this angle. Let me write that. Okay, so that would be angle CBA is congruent to angle DCB. Now, how do I know that? Well, because they are alternate interior angles. They are congruent because they are alternate interior angles. So take a look at this. The triangles are congruent because of angle, side, angle. Let me get the triangles. Okay, so the first triangle here on the left is ACB. So triangle ACB is congruent to triangle, the one on the right, which is CBD. So these two triangles are congruent. Why are they congruent? Well, they are congruent because angle, side, angle. They are congruent. Well, now, because these two triangles are congruent, sorry for the music. I think you can hear it. There's music outside. Yes. Okay. So, because these two triangles are congruent, well, therefore, I can say that all the other pieces are congruent. And check. We're trying to prove that angle CAB is congruent to angle CDB. CAB would be this angle right here. And CDB would be this angle right here. If you notice these angles right here, they are corresponding angles. Because I have shown that the two triangles are congruent, that means these corresponding angles are also congruent. And again, that is called CPCTC. Corresponding parts of congruent triangles are congruent. This is what I want to prove, so it's definitely the thing that you want to prove, it's always going to be like in the end of the proof, okay? And the reason for this is again CPCTC. CPCTC. And that's it. We are done with proof number 6. Okay. Now, question 7. Question 7, it's pretty simple. I don't think I ever taught you this. But if I didn't, here's a chance for me to teach it to you. And it's pretty straightforward. All the angles inside of a triangle, always, any type of triangle, all the angles inside of a triangle always add up to 180. So this angle right here is 60. This angle right here is 40. Both of them together make up 100. Now the question is, how much more do I need to get to 180? I need 80. That means angle A equals 80 degrees. Okay, and it has to make sense. You can double check. Well, if angle A is 80 degrees, right? 80 degrees. If angle A is 80 and 40 and 60, all of the three together have to add up to 180, and they do. 60 plus 40 plus 80, it's 180. So A is 80. That's it. Oh, and that's it. That's the whole study guide. Pretty straightforward. Okay. Right here, these parts right here are actually solutions that you will see on the test. Technically, I'm giving you the solutions right here. Okay, so for question 10, the solution is B. Question 15, the solutions is parallel, pre-image, and image. 16 is perpendicular, bisector, equidistant, and line of reflection. I'll remind you of this on the test, but this is it. Oh, question 2. I almost skipped it. Okay, this is not it. So, question 2. Proving lines. Well, I want to prove angle 1 is congruent to angle 3. Okay, to prove that, angle 1 and angle 3, these are the angles, okay? I can use anything. Angle 1 and angle 3 are vertical angles, so I can use anything I want except vertical angles, because that is what I want to prove. So I can use anything except vertical angles, again, because that is what I want to prove. Now, remember that I told you that if you want to prove angle 1 is equals to angle 3, we are going to be using supplementary angles, okay? Now, within these supplementary angles, you have many options. You can choose these two supplementary angles, 1 and 2. You can choose these two supplementary angles, 3 and 4. You can choose these two, which is 1 and 4. And you can also choose these two, 2 and 3. There's 4 options. You only have to choose 2 of them, okay? You want to make sure that you choose angle 1 and angle 3. And you also want to make sure that you are choosing one other angle twice, okay? So this is how I'm going to choose them. Angle 1 and angle 2, and angle 3 and angle 2. If you notice, I'm choosing angle 1, angle 2, and I am choosing one other angle twice. Okay, so here's how it's going to go. Let me see if I can write in, if I can type in here. Yes, I can. Okay, so here's how this is going to go. I have that the measurement of angle 1 plus measurement of angle 2 equals 180. Okay, that would be these two. That's my first line. Second line, I have measurement of angle 3 plus measurement of angle 2 also equals 180. Okay, I have these two statements right now so far. Okay, the reason for both of these is the same. These angles are supplementary. These angles are supplementary as well. Okay, that is true so far. The two angles that these two are supplementary. Now here's the thing. If you notice, these two angles right here equals 180, and these two also equals 180. That means that these two right here on the left are the same as these two, because both of them are equal to the same thing. Well, that means, therefore, I can say the following statement. I can say that these angles right here, measurement of angle 1 plus measurement of angle 2, is equals to these angles right here, measurement of angle 3 plus measurement of angle 2. They are going to be the same. Okay, they have to be the same. So this one's on the left and this one's on the right. They're both equal to each other. Now, the reason for that is what's the name of the reason? The transitive property. Okay, transitive property. This is it, transitive property. Okay, now after this step, here's what I want to do. I'm actually going to need my writing tool. Here's what I want to do. After getting the transitive property, what I'm going to do is I'm just going to make use of some algebra. I'm going to get rid of measurement of angle 2 by subtracting the measurement of angle 2. It's an equation, okay? Here's the equal sign. It's an equation. So what I do to one side, I also need to do it on the other side. So on the other side, I'm also going to subtract the measurement of angle 2. Now this is good. This is nice, because once I do this, technically, right here on the left side, these will cancel out. Same thing on the right side, these will also cancel out. And if you notice, I'm left with measurement of angle 1 being congruent to the measurement of angle 3. So measurement of angle 1 equals measurement of angle 3. This is what I'm left with. After getting rid of these angles, this is what I'm left with, okay? Now, this step right here, where I subtracted to both sides, that also has a name, and that is called the additive inverse. And I'm sorry that it's not perfectly aligned, okay? But this goes with this step where I subtracted to both sides. That's called the additive inverse. And technically, once I get this, this is it. This is my solution. All right. I'm done. I have proven measurement of angle 1 is equal to measurement of angle 3. Therefore, angle 1 is congruent to angle 3. And this is the whole proof. Sorry that I didn't provide a table for this one, but it's still the same thing. It's still the same, the statement. Statement and reason. Statement and reason. Okay? So it's the same process, it's still a table, and this is it. Supplementary, transitive, additive inverse to prove measurement of angle 1 is congruent to measurement of angle 3. And this is it.